All right, this is 9.2, Adept. So we're going to continue on with elimination, but call this level 2. So the equations are just a little bit more complicated, but not much. So here I have a system of linear equations, and I have a series of steps that we're going to go through one by one that will help us get to the solution. So step 1 says to adjust the system by lining up the terms vertically. So you noticed before in the previous video when we added the equations together, all of the x's and y's and the numbers were all lined up. So we're going to have to change the order here. We're going to do that in just a sec. Step number 2, we are going to choose which variable we want to eliminate. Okay, so this is something we haven't quite seen before. So before we actually get to step 2, let's just complete step 1. So let's go over here. There we go. So the system was 3x equals 11 minus 7y. So let's line everything up. So that's going to give me 3x plus 7y equals 11. Okay. The next equation, okay, the x's and y's are on the side that we want, but we just need to reverse the order. So this becomes 4x minus 2y equals, and we need to get rid of that positive 8. So subtract 8 from both sides. So I get negative 8 over here. All right, so that is the system that we had, but everything is lined up now. So in the previous video, all we did is we just added up the equations together. But hopefully you notice that with this example here, that's not really going to help us, because notice how these coefficients for x, they're not equal and opposite. Neither are the y's. So what we need to do first is adjust one or both of these equations. So let's first make a choice. Which variable do we want to disappear? Which one do we want to eliminate? Let's choose x. So this is step 2. Let's eliminate x. So for that to happen, these coefficients here have to be equal by size and opposite in sign. So let's do that. 3 and 4. The smallest number that both of them go into is 12. So I'm going to multiply this by 4. But what you do to one side, you must do to the other. So I need to multiply this side by 4 as well. I'll keep this in brackets here. Okay? And this equation, okay, I'm going to multiply this by negative 3. Which means I have to multiply this side by negative 3. Okay? So you may ask, why am I doing this? Well, when we apply distributive law here and here, you will notice something. So let's do that. So we're going to get 12x plus 28y equals 44. And this is negative 12x plus 6y, watch your signs, equals positive 24. Okay, so this is my new system of equations. It's just a disguised version of the original set. But look at my x coefficients. This is positive 12. This is negative 12. So now, when I add these together, the x's are actually going to cancel out. So we've done step 2, we have done step 3, now we're on to step 4, that is adding and solving. So let's add them going down. 12x plus negative 12x, that's just 0. I'm not even going to write anything. Positive 28y plus 6y is going to give me positive 34y equals, and 44 plus 24 is 68. Okay, so this result, we just have y's, we don't have x's anymore, we eliminated them. So we can just divide everything by 34. This cancels, and I get y is equal to 68 divided by 34 is 2. There we go. So we've actually solved for y. We're almost done. We need to solve for x. And as we did in the previous video, we can choose any equation we want. We could choose one of the modified ones, which I probably wouldn't do because the numbers are a little bit bigger. So I'm going to use one of the original ones. It's up to you. I'll use the top one. So this is 3x plus 7y equals 11. But I know that y is 2. So I'm just going to replace y with 2. And now I can solve for x. So this is 3x plus 14 equals 11. I need to subtract 14 from both sides. So that's going to give me negative 3. And dividing both sides by 3, I get a nice result. Negative 1. Okay, so there's my system.